Okay, welcome back everybody. I hope you had a good lunch. I'm Eddie Murphy. I'm the current president of ASHRAE UK Midlands section. This is my last engagement. And hopefully now that I'll go out on a bit of a blaze of glory with some fine topics this afternoon. First up, I've got Dave Cooking from DesignBuilder. He'll be followed by a couple of other speakers, and then we'll have our fantastic distinguished lecturer, Dennis Knight, who'll follow at the very end of the proceedings. So, if you want to take it away.
Thank you very much, Eddie. Good afternoon, ladies and gents. I have, it seems, the dubious honour of presenting immediately after lunch in what's often called the graveyard shift. So, should any of you fancy a nap, beware, Eddie, Yi, Lubo have all been primed to pounce. Hopefully what I've got to say is interesting enough that that won't happen. I am going to start with about 10 minutes of slides, and then the main focus will be on a live demonstration, really to highlight DesignBuilder's workflow and point out some new features. I really do want to show that DesignBuilder is a tool that can be used from the very early stage all the way through compliance and into detailed design. In the kind of context of the presentation itself, or the event itself, sorry, those of you familiar with DesignBuilder will be more accustomed to hear us talking about more sophisticated modelling aspects like detailed HVAC, optimization, EMS scripting tools, etc. Today will be different. Last month we gained approval for DSM, or Level 5, UK compliance tool. So my main aim today is going to be to show you how we can set up a compliance model, do some early stage stuff, and then migrate through compliance into more detailed modelling, and then repurpose the model later, perhaps do some daylighting analysis, etc. All from that same base core model. So for those that aren't familiar with DesignBuilder, what is it? We like to think of it as a fully integrated, multidisciplinary toolbox, essentially. It's basically a GUI, the aim being to provide you with faster, easier, more productive ways to use some really powerful open source engines that sit behind the GUI. Engines like Energy Plus and Radiance that you've heard all about already today. It is fully integrated, so all of these analyses that you see here on the screen, cost, HVAC, certification, daylighting, visualization, CFD, optimization, etc., all done from that single base core model. It's the most capable and mature third-party interface to Energy Plus, the engine from the US DOE. And we've got a global customer base, around about 2,500 customers, including firms like ASHRAE, leading universities like Loughborough, MIT, etc. So DesignBuilder can be used for a range of certification and code compliance activities. We all know that modelling to codes and standards, certainly within industry, is often done to very tight timescales and very tight margins. We've had to work really hard to develop a tool or a workflow that gives, we think, our customers a competitive advantage. So all of the analyses that you can see here, building regulations, EPCs, BREEAM, TM52 overheating, etc. Not to mention LEED for international use. Given this is an ASHRAE event, I can't not mention our LEED tools and ASHRAE 90.1, baseline modelling for LEED. There isn't too much of that happening in the UK, but there is some. BREEAM obviously still dominates in most European countries. You can generate a baseline building automatically, straight from the proposed building, and then automate the HVAC system baseline generation as well. In the summer, more automation tools will be released in a new version, along with online lead reporting for anybody that's doing that stuff. You can import from and to mainstream BIM tools, including a Revit plugin, to load the model direct into DesignBuilder. One perhaps slightly unusual feature is the ability to group the zones, etc., which makes navigation within the model that much easier later on down, especially if you've got a lot of zones in your building. A lot of our customers don't have access to BIM models, and they much prefer just to use our geometry creation tools. I think it's fair to say that DesignBuilder has by far the most powerful and user-friendly geometric tools. You can create the models very quickly and easily. All of the normal stuff you'd expect from an engine like Energy Plus, environmental comfort, detail node analysis. We've got a results viewer tool that enables you to drill right down to the nth degree, look at every time step, what's happening at every node in that detailed HVAC system, for example, and do comparative analysis on multiple simulation sets. A number of different tools for those doing HVAC and engineering. We do have a simple early stage kind of HVAC modelling capability that's nice and quick to set up, but you can very easily switch to the more detailed HVAC modelling, and it uses a schematic kind of system, either by loading in existing templates or by building up the system and connecting it component by component yourself. And we can quickly run load calculations to determine plant and emitter sizes at design conditions. Lots of solar analysis and visualization tools, flexible, fast ways to apply different glazing systems, different shading systems, those areas of the model which can take an awful long time when you've got lots and lots of different things going on in different areas. Lots of rendering and visualization tools. For those of you using DesignBuilder already, you probably won't have seen this before. Solar incident on facades. This is one of the new features that we'll be introducing in the new release in the summer, which is currently in beta form. Fully integrated daylighting analysis. So we use the same model, but we just open up a daylighting calculation tab. We use radiance at present for our daylighting, so we can generate daylight factors. And also in the latest beta is an implementation of DaySim, so we can do climate-based daylight modelling, daylight autonomy, etc. There are CFD tools, again fully integrated with the model. So you click on the CFD tab and you can run external analysis. You might want to look at pedestrian comfort or siting of wind turbines or HVAC intakes. Or you might want to do internal analysis for comfort. It is a simple, light CFD engine. Okay, it's not like ANSYS or one of those more complex tools. Internal analysis involves just simple comfort, airflows, temperatures, pressures, velocities. Useful for most people, most of the time, at a fraction of the cost and a fraction of the time to produce the CFD outputs. Particularly useful for nap vent analysis, etc. You can also link your, because DesignBuilder is fully integrated, you can output your thermal simulation results, so all those surface temperatures, window temperatures, airflows through openings, and use those as boundary conditions or starting points for your CFD analysis. So saving an awful lot of time and effort. There are also a lot of advanced features, so you can export the input data file for Energy Plus and mess about with that should you want to. You can use the energy management system to write your own scripts to tailor and tweak the simulation. And then for the expert level, you've got the kind of FMU, functional mock-up unit, and all the way to modifying the source code. It is open source. You can also use the model for cost, life cycle cost, and life cycle analysis modelling. By default, it's a simple cost model, but you can select a RICS, NRM1 format output, and if I get time, I'll show you that later. That data, every component within DesignBuilder automatically has a cost assigned to it by default, which you can edit. That data is then used for, obviously for cost modelling, but also for optimisation purposes, where you're doing kind of advanced cost-benefit analysis. There are large libraries of materials and systems within DesignBuilder that include that cost data, and also include embodied carbon data for life cycle analysis. So optimization. A couple of presenters have already touched on this. It's basically a tool that hopefully allows you to cut through that complexity of all those conflicting design variables. You know, what happens if I increase my air tightness and I increase my cooling loads, or I reduce my lighting and my reduce my lighting loads and my heating consumption goes up. So it enables you to take a holistic view. Buildings are ecosystems, fully interconnected. It's no good looking at one element, changing one element a lot of the time. You need that kind of level of interconnectedness and a visibility of the view of it in order to properly assess what's happening as you're going through early stage and then perhaps onto more detailed stages. Which HVAC system best meets the building that I've got with that amount of thermal mass in it? All of these things, optimization really does help you to flush out. I think it's probably fair to say that DesignBuilder has got the most mature commercial optimization tool. I'm sure Yi will put me right when he talks about optimization later, if that's not correct. But we've been doing this for a while now. So our focus now is on developing complementary uncertainty and sensitivity analysis tools. We want to make sense of that range of results that the optimization analysis will give you. So that's basically the slides, a simple introduction to the interface. So I'll now spend the rest of the time using the software. Okay, what I'm hoping to do is basically to set up a compliance model. So you can see here, I've got a blank model set up and I've chosen to do a DSM analysis. So it'll be a UK compliance model that I'll set up and configure it, and then we'll flip modes and see how that data carries through into the Energy Plus simulation for more detailed analysis, etc. as we go through. So I'm going to assume that this is an existing building, so we've got no GBXML or we've got no 2D floor plans, which of course we could import if we had. So I'll give you a quick idea of some of DesignBuilder's geometry creation tools and quickly create the building form. So in DesignBuilder we create buildings by adding one or more blocks, and in this case I'll just create a block. Simple rectangle to start with. I'll start from the origin here, and let's say it's 30 square meters, so type in 30 space 30, hit the enter key, and that will create my simple rectangular block. Once we've got some geometry in Design Builder, it's very easy to edit it, to stretch it, to cut it, to shape it, push it, pull it. So I'm going to use this, this little tool here, and I'm going to basically just take a chunk out of this, this south facade here, 10 metres in, and 10 metres across, and I'll come back 10 metres. So I'm going to create effectively a simple horseshoe shape. Okay? Once I've done that, I'm going to add another block on top of it, and this time I'll draw in the vertical plane and create a monopitch roof. So I'll just do that, and I'll choose an apex that is let's say an apex of 6 metres up there, and I'll come back down, snap there to 3 metres and back this way, and pick up a snap point on that end facade, and that will line that end up with my existing one. Once I've got a block there, to create the monopitch on the other side, I can use a little mirror tool here, and very simply mirror that in the y-axis here, pick up a snap point and drop it onto the other side. So let's assume that's my early stage geometry complete. I might then want to look at the internal geometry. So I can create zones very easily using this partition tool. So I'll just literally put in a couple of opaque partitions. I could very simply select a virtual partition to subdivide zones without adding any mass, etc. But these are standard opaque partitions. Okay. Quite often, the design changes through the course of a project, so we may need to update the internal geometry, external geometry. So these geometry tools that we use to create the original stuff, or if we've got a BIM model, we can very quickly and easily use those tools again, just to change that geometry that we've already created. So I want to raise that up by, let's say, 3 metres, and I can just create a 6 metre high centre section in that inner core zone there. Okay, I can see here that my this facade is stepped. Well, I don't want that, so I'm going to select that facade, simply pick it up and just extrude it to that section there. Okay, so we can edit and tweak the model as we go through. Okay, once we've created our external geometry, then we can start thinking about naming our zones and adding data to our model. So I'm going to, if I go back to the block level, if I look here at the plan view, the middle zone here is zone 3. So if I go to zone 3 there, I'll call that my reception. Okay, so now we're at the point where we can start adding model data. So within Design Builder, you can do this very simply, and there's a nice logical workflow from left to right working through the data tabs there. So I'll start with the activity tab. I'll go to building level here on the left, go to the activity tab. In Design Builder, a lot of data is template driven, and this is a UK NCM model, compliance model. So the templates, in some respects, are restricted. You can see all the data that sits behind them, all of the NCM data here on the right, but the activity data is just basically there to select the correct activity. Everything else is constrained. So the way that Design Builder uses these templates, it uses a data hierarchy and an inheritance mechanism. So the hierarchy is that data flows from the site level at the top here, top left, through the building, through the blocks, zones, and down through the surfaces and the openings that sit below them. So data flow down the hierarchy. So if I set an activity at the building level here, it's set all the way through. So as soon as this is a 100-zone office building, 80%, 80 zones might be offices. So I've already populated 80 zones. I just need to go now to the other 20 and assign a different activity. So I'll go to the reception zone there, and I'll just select from the list here the reception activity. All of those templates and activity data is already preloaded into the software. So that's my activity assignment done. Obviously, the less data you have to input and change, the less time it takes, but also the less likelihood of you making a mistake. Okay, so moving on quickly to the construction tab. This is where we define our thermal envelope, the opaque aspects of the thermal envelope. So it's our walls, floors, roof, etc. Again, we use templates to quickly load bulk data. So here you can see there's a project template by default, and it's all project data. If I open up my little library of templates, there are some predefined ones. So there's a timber frame super insulated. I'll load that here at the building level, and then every zone, every surface in that model will then inherit this data that you see here. That's all changed, it's been updated. If you work on NHS a lot, or defence or retail, you might have certain templates. You just pre-configure them, load them into the model, and then just apply them. So a really quick way of handling data. So we can, of course, change any of the data that we've that's been loaded by the template. So I'll create a new external wall. So here, I just click on Add New Wall. I'll call it something DSM Wall here. We can specify data in different ways. Energy Plus uses layers. Within Design Builder, we found ways to be able to utilise UK NCM data like inference procedures, library procedures. It's all very well using layers, and it's great for new builds where you've got that information, but what when you haven't? What when you're surveying an existing building? You don't know what's in that wall construction. So we can tie that back to the age of the building, the sector, etc. So I can select perhaps the inference option here, select the sector as office, select the age of the building, so if I choose 2010, and then perhaps as I've used a timber frame, so I've got a weatherboarding system. So that sets all the data that Energy Plus needs to evaluate that in a simple way. Obviously, if you can use the layers option, it is much better. You've got much more control over the data. So I'm just going to click on OK to create that construction and load it into the model. Okay, so that's my DSM wall now loaded at the building level, and that will apply to all of the walls in my building. Openings tab, again, template driven. Hopefully you get the idea by now. I'm not going to set up a new window construction, but the same principles and the same kind of inference library or Energy Plus options apply. So we can set them up very quickly if we want to. I will load here already a best practice template, so I'll load that, and that will set all of the data below, but I won't edit it this time. So that will be inherited by all the windows in my building as it stands. These facades options, they're basically used for quick early stage design. Do I want to do a quick parametric or analysis on percentage window to wall ratios? What are the effects on cooling loads, etc. if I change that stuff? Or we can simply change them at any level. So if I choose, let's say 25%, that will just update all of the glazing across my building. Of course, that won't be like that in a lot of cases. So I might need to navigate to one surface. So let's say I choose the north wall on my reception zone. Let's assume that's fully glazed, so I'll fill that surface with glass using the drop-down tools. We don't have to apply glazing by using those kind of numerical and input data. We can, if we want, draw glazing onto our building. So if I go to, let's say, this surface here, I might want to just draw a couple of large openings for that. So I can just use the draw window tool. Let's say I've got a window here that's 10 meters wide by, let's say, 1.5 high. Hit the enter key. That's my window. I can copy that at surface level. So clone that and just copy that along and drop it there. And once we've defined one of each of the sizes of our glazing in our building, we can then copy it at building level and populate the rest of the model. So here, for example, I might want to copy those windows onto another surface. So I can pick those up, just drag them and drop them there as roof lights, for example. Okay. So going back to the openings tab there, we've got different ways of handling shading. We can draw shading devices onto our model, things like large canopies, etc. Or we can use, we can apply window shading. So window shading in this Energy Plus context is things like, if I click on the item here, you can see the library, diffusing shades, electrochromic glazing, blinds, transparent insulation. We can select the position and we can select the way that those systems are controlled. Local shading, we can apply in very much the same way. So local shading is overhangs, side fins, louvers. We've got quite a neat tool, which I'd like to show you here, is a load data from template tool. So I can use this really well for glazing and shading. So for example, I could pick a double glazing system with louvers. I want to apply that. And I can select where I want to apply that data. So I can choose as zones or surfaces, use the hierarchy, or I can ignore the hierarchy and use selection filters. So I want to apply that data here, let's say 30 degrees either side of due south. Okay, so from 150 through to any facade that is orientated 30 degrees either side of south, this data will be applied to it. So I can also filter by the slope of a surface, or by if a surface is over a certain area, or even where I have templates with certain names. We can tag templates, and that's really useful for optimization purposes as well. So I'm going to click on OK, and OK that, and what I hope to see when I go back to the model is that on the south circuit, I think hopefully you can see that, you can see that those louvers have been applied to all of the south-facing surfaces. You can see the orientation marker there with north to the left of the screen. If I rotate around a little, you can also see there the fully glazed reception. Okay, so that's a brief overview of some of the glazing tools. Lighting, really simple, normal NCM stuff. So let's say I'm just going to choose an LED lighting system, and I'm going to switch on photoelectric control and occupancy sensing. Obviously I could add more data, but I think just to give you a quick flavour of the way things are handled, that's sufficient. HVAC systems, very similar in an NCM context. So I can add a new HVAC system, choose the system type from the NCM list. So let's say this is let's say it's a VRF system, small commercial building, perfect. So split or multi-split. I can assign an electric heat pump, grid supplied electricity. Let's say it's got a seasonal efficiency of 5. Define the cooling parameters. Again, VRF heat pump, electricity, and I can choose, let's say...
10 minutes there, Dave.
Okay, thanks, Eddie. Yeah, and a value for that. Okay. So, that's my HVAC system set. And I'll now run a quick simulation. Okay, I'll run a quick EPC England simulation and just show you a couple of the outputs. This uses a simulation manager, which is a similar tool to Cormac mentioned at IES this morning. So it fires the stuff off basically, and it runs those actual notional and reference buildings, runs them all in parallel, and I'm just going to minimise that and quickly go back to the slides while it runs, just so you can take a look at some of the new features. Yeah, so the simulation manager basically enables you to fire the stuff off away from your local machine, to run stuff on remote servers such as Yee's Jess online server, which is essential for optimization, etc. So, major new features coming up: visualization, false color rendering, climate-based daylighting, lots of new adaptive comfort nap vent options, RICS cost modelling, the ability to use custom design variables, the Energy Plus EMS, in optimization, and also a hookup to Yee's JE8 engine. New cost methods are also hooked up to optimization, agent-based cost modelling, and multi-state electrochromic glazing. So back to the model. We can see here just a summary of the results. So we've got comparisons with BERs and TERs, and we've got comparison there with the actual notional reference building. So you can see on a system-by-system basis how where your problems lie, if you have any problems. If I wanted to run Part L calculation to generate Bruckle document, click on that tab, go through the same process. I'm not going to do that now. In fact, I should just show the EPC. Obviously, most of you have seen these things before, but that's based on the model data that I've just input. So I'm going to quickly switch modes now and show you. So we could switch to SBEM, do a direct compliance comparison, but I'm going to switch to Energy Plus and take a look at some slightly more funky functionality. Some of the stuff you're more familiar with seeing in DesignBuilder. One thing I'd like to point out is that all of the data that we've input already, so our reception data here, all this carries through when we change the model over to more detailed analysis. And we might want to use this model for TM52 analysis or detailed HVAC system energy comfort design, etc. Constructions data, the same. So at building level, I've got my timber frame, DSM wall, best practice there. Lighting data actually hasn't, so I can switch on photoelectric control, and my HVAC system split or multi-split system. So I'm ready to start running some calculations. I can use this model now to run heating design calcs. Let's do a quick cooling design calculations. So we can choose which months to run those calculations from. I'll just leave it set to the standard Energy Plus ASHRAE options, just to show you the kind of outputs that you can generate so quickly. So here we can see that design day, worst case day, or is it the worst case? I've set a range of months, so I can look here at June, or I can select this peak option here, and that's telling me that the peak month actually is July in this scenario. And we won't look at these in detail, but you can see quite clearly when I look at my heat balance here that we've actually got a problem with our roof. So we've gained an awful lot of heat through our roof that's having to be offset with our cooling system. We'd also get a summary tab that gives us the design capacity of our emitters and the design capacity of our total plant. We can run a simulation very quickly, and I'll run one from, let's say, the 1st of July to the 31st of July, and choose hourly data, and let's just run that, default conditions. So then we can start to get a better handle on things like comfort conditions within each zone. Is that HVAC system that I've got able to meet the loads? So I've used the simulation manager, so it's stored that result set for me. I can either load that into the results viewer, or I can load it into the DesignBuilder interface, and I'll do that quickly. I haven't got time to look at the results viewer, but here we can see the energy consumptions for the whole month broken down by system. If I go to hourly results, I can see building level results for things like lighting, electricity, go down to each of my zones, and I can start to see the normal stuff that you're familiar with, your heat balance, comfort temperatures, etc. So I can also very quickly from the same model run a daylighting simulation. So if I go here to my building level, go to my activity tab, and I'm just going to switch on daylighting in these zones, and go back to my daylighting tab at the block level, and I'll just run a quick daylighting calculation. I'll use the BREEAM option, and this will pre-configure all of the inputs that BREEAM require for a compliant report. I'll use the fast option, obviously not got a huge amount of time, and we'll just generate a report that covers that block of my building, and we'll also get a map view showing the illuminance at the working plane. So here's my BREEAM report. Obviously I've got 25% glazing, I've got some fairly deep plan zones, so the building itself failed. Not a disaster, it's given us information. I can do something about it now. The beauty of this is the integration. If I make changes on one side, I might say, right, I want to improve my daylighting. Then because it's fully integrated, I can see immediately the effect on my cooling systems. So that's really useful. The last thing I'm going to show very quickly is...
2 minutes, Dave.
2 minutes, yeah, is just the cost and carbon. So if I click onto the cost data here, I can choose the RICS NRM1 cost, and I'm just going to run a quick cost calculation, and that will use all the RICS formatting to produce me a report, because all of the model data has a cost associated with it, which of course you can edit and change. So there's my RICS report, which I can output. I don't have time to do the CFD, but literally probably take me a couple of minutes to set up a CFD model in the same way. That was a pretty quick canter through the software, but hopefully I've got the point across that you can use an energy model, set it up, and take it from early stage all the way through to do some quite detailed analysis.
Thanks for that, Dave. Just a few minutes for some questions, if anybody's got some. One question.
In the daylight analysis, are you able to do the thick wall? Is that thin wall model only?
You can. There are different model options, so you can choose whether to use a very, let's say, the defaults for wall thickness for UK NCM are thin walls, because all of the heat loss areas are basically defined from the internal surfaces of the building. But we can very easily select a thick wall model, and then obviously take into account the effects of reveals and all of that. Yes?
Any more? Oh, we're on the far end. You have to shout.
Hi Dave.
Hi John.
Can your compliance checks with that be used as a constraint in your optimization? Or is that asking too much?
I'd love to be able to say yes, because it's like the panacea, I guess, of compliance modelling. Click a button and hey presto, there you go. The challenge is, and I think the previous presentation from Equa touched on this, compliance modelling is constrained to death. Because even though it's dynamic simulation, first and foremost, it has to comply with the UK NCM constraints. So it isn't a straight Energy Plus simulation. It's tweaked and post-processed in order to generate the client's the certification outputs. So unfortunately, the answer is no.
Okay, I'll think. Is there any more? Just one more. If there's... Okay, well, we'll wrap it up there then, and we'll have our next speaker, who's from Tian Building Engineering, to talk about the